It's another nice evening in the shop, so I'm going to get started on the body. The body is by far the hardest part to make in the entire project, and that's because you have a series of bores that run all the way through the part, and you want to make those as concentric as possible, and they are relatively small in diameter compared to their lengths. So the first one you have is that here at the back, you have the threaded section that's 5/8 18 that the plug will sit in. You have a narrow clearance section here that you can use so you can actually thread the back section. You have a 1/2 inch diameter by 1 1/4 inch long bore that the collar on the back of the diamond rides in. And then you have a 3/8 inch by 1 inch bore here that the actual diamond body rides in. So to make this, because it's relatively long compared to the size of the bores, it's going to be an interesting process. I'm going to chuck it up once, get it down to length, and then I'm going to drill and bore and go back and forth a couple times so I can get all the way through the part, and that everything's as concentric as possible. Then I'll just be turning it around to put this chamfer on the front of the part, and that's just for clearance. So let me move everything around here and we'll get started. I've already gone ahead and faced both ends of the blank and determined that I need to take 230 thousandths off. So since I want to do this fairly accurately, I'm going to use the Sharpie trick. That's now down to length, so I can start drilling holes. Okay, that should be far enough in to do the first handful of bores. As you might expect with a bar sticking out this far, there is a high probability of chatter, and I've experienced quite a bit of it so far, but I think I've got it to the point where it's minimized about as good as I can get it. So I'm going to go ahead and keep making some more passes. I'll try and add in some footage of the actual boring if I can get any that's really good. I was never able to completely get rid of the chatter, though I was able to minimize it down to the point that it wasn't much of a problem. What I did to do that was I shortened the projection of the boring bar. I'd originally had it sticking out 3 inches, which would have given me enough to go all the way through if I wanted to. And I will have to increase the projection again when I go to drill the hole and bore it and ream it for the diamond to ride in. But this was enough for this. The other two things I did was I increased the feed from 3 thousandths per rev to 6, and then I dropped the RPM from 1,000 down to 420. And then as long as I kept the depth of cut between 2 thousandths and 5 thousandths, the chatter seemed to be minimized. I've already measured it, but let me show you. This is a 1/2 inch drill blank that's right on 1/2 inch, and it fits in the hole fine. And then here's the diamond, which is actually a few thousandths under. I think it's 2.5 thousandths under, and it just slides right in there fine. So what I'm going to do is I'm going to switch out to a more stout boring bar so I can drill the minor diameter for the threaded section. And that's it for that bore. Now it's time to cut the thread recess. That's it for the thread relief. Maybe you can see it down in there. Got a little. There we go. That's the last little bit of debris. Let me switch the gears around and the cutter, and we'll come back and we'll thread this. Okay, so to clean up the chatter, all I did was move the compound in. It's at 30 degrees, well, actually it's at like 29.5, 30, close enough. Just moved it in about 2/1000ths, and that was enough to clean up the chatter and give me a nice fit. So now it goes all the way in and seats like I want it to. So the last thing to do here at the lathe is to drill bore, which is going to generate all that chatter again, and then ream the through hole for the diamond itself. There we go. Hole is all the way through. Now it's time to break out the boring bar. So I've gone ahead and set the boring bar and everything up off camera. Right now the bar just fits in. And then I've also gone ahead and set up my dial indicator here. So I know when this comes around and reads 100/1000ths, the tip of the bar is out the back and I can hit the power feed off. So let's get started. Hopefully you could hear that chatter. You know, I've been trying to minimize it, but it was there, that really high-pitched whine. That was that boring bar chattering in that hole, which isn't really a problem because we're going to ream it anyway. But I think that boring bar was stuck out 7.5 times its diameter. So, you know, that's inevitable. I mean, it wasn't a tuned bar or anything like that. It's just a regular solid carbide bar. Now it's time to ream it. And I have to stick this pretty far in. I've already put a bunch of cutting fluid in there. There, so I'm bottomed out. So right there is good enough. Lock the tailstock down. And then get started. And there I'm out the back. And that's it, holes reamed. Everything should be perfectly concentric with each other. And you might have noticed, I'll point this out now, it looks like it's running out quite a bit. It's only running out about 5.5 thousandths, and a big chunk of that is actually a lump in the material. It's not perfectly round. So it looks a lot worse than it actually is. Okay, let's turn it around and then put the chamfer on the face, and then we'll be done at the lathe. So I've gone ahead, switched everything around, set the compound to 15 degrees and done a couple test cuts. Everything looks like it's going to work well, so now it's just a matter of actually doing it. So the tolerance on this is pretty wide. It's supposed to be 0.9 inches plus or minus 10 thousandths. And as you can see, I got quite a ways to go. I'm just going to come back and forth and keep checking it like this. And that's close enough. So all I'm going to do is take a file now and kind of round this edge over because it's kind of sharp. There we go, that feels good in the hand. So with that, well, let's see. I really cranked down on this. There we go. This part is done here at the lathe. Everything else in this project is going to be done at the mill. And in case you were wondering, this is how I was spinning the compound. Center goes into the center in the back of the lead screw, and this just bears against the handle, and that's it. I've got the body clamped up here in the vise with parallels that are just thick enough so that I can get a pair of dial calipers underneath to measure the thickness as I remove material. I've already set my depth of cut and my speed and feed, so let's get started. Okay, that's as far as I can go on the face mill. I'm going to switch over to my fly cutter just because I want to get a nice smooth flat surface. Now that the bottom is decked off, it's time to drill it and tap it so that the guide bar can be mounted to it. So that's it for the bottom. Now all I have to do is flip it over, re-indicate everything, and then I'll drill the hole for the lockdown screw. And that is it for the body. Last step is to make the guide itself, and that's going to be dirt simple. So the guide is now machined down to size. Now all I have to do is drill the through holes and then counterbore them for these flathead cap screws. And that should be the last operation. Let's check it. Yep, it's down underneath. And this is a little trick I like to use when I'm doing stuff like this. Just take a little, well, take a magnet and don't get it stuck fast to the work. But get it stuck fast to the top of the screw, and then you can pull it up out. Okay, let me take this over to the bench, do a little deburring, and I'll bring you back when I'm ready to do the final assembly. It's been 2 days since I finished the machining, and in that time you can see I painted the body. Hopefully that'll keep it from rusting too much. So now it's time to put it together and show you how it works. So again, diamond with the collar on the back, slide the spring over top, slide that into the body, insert the plug, can lock that down. There we go. And you want to put the base on now, at least in my opinion. Make sure I have that lined up the right way. Yes. So this is the reason why there's 4 holes. So you can rotate it this way or this way and push to the left or pull to the right, whatever way you want to think about it. You can do both. And just run the cap screws in. Come on, there we go. The hex on these cap screws are particularly tight. Okay. So next step is the fine adjustment screw. And the reason I picked 1032 is because you get a lot of adjustment out of it, a lot of accuracy, I guess is a good way of putting it. You have to rotate this screw, I think it's 11¼ degrees to get 1/1000th of projection of the diamond. So when you're machining off the front of the diamond, or not the front of the diamond, the front of the wheel, you can just make a tiny adjustment, make a pass, make another one. That way you don't have to take off any more of your wheel than you need to. And then the last thing here is the lockdown screw. That's what it looks like. So to use this, get everything set up, loosen the lockdown screw, increase the projection a little bit, lock it back down and make a pass. So let me move the camera over to the grinder and I'll show you how that works. Okay, so it took a couple tries, but I've got the grinder, I think, in a space now where I can safely videotape it without worrying about damaging my lens and still give you a good shot. So let me turn this on. Let me stand to the side here while the wheel spins up. Now I've already gone ahead and dressed this so it won't take much, but I apologize if this is a little bit shaky. Since I've moved the grinder, it's probably not as stable as it should be. It's not going to fall over or anything, but it's shaking just a little bit. That should be good enough. It'll take a second for this to spin down. So there we go. A wheel with a nice true face. And it feels like the pores are fairly open. So this is good to go now. I hope you enjoyed the project. I know I did. I plan on having this probably the rest of my life. So I'll see you guys all on the next video.